Chapter 8, Lesson 4, we are going to be doing quadratic inequalities today. So we will be using our solving quadratic equation skills. So our complete the square, factoring, and quadratic formula. But we're going to be doing inequalities, which are less thans, greater thans, or equal tos, and rather than equal signs. Okay, go ahead and pause here and take these notes. Okay, so this first one, they've already factored for us, which is nice. So we just have to go about solving this. So I would solve this one as x equals -1, and this one as x equals -5. So I go ahead and put them on a number line. -5 would be on the left of -1. And I know they're both going to be solid circles because of the way this is set up. And so I have to check, though, to see which way the arrows will point. So what I like to do is start with checking something in the middle. Something in between here would be -3. And so I'm going to check to see if that's a solution of this equation. So I'm going to put -3 plus 1 times -3 plus 5 in my calculator and see if it is less than or equal to 0. It gives me -4, which is less than or equal to 0. So I know that these arrows have to point towards the -3. On the second one, it is not factored for us. We could do this any of the three ways, but I'm going to choose factoring because I know it's going to be the quickest. Factors of 15 that add up to 8 are 5 and 3. Sign chart says they're both plus. So this one would give me -3, and this would give me -5. I'm going to pick something, it doesn't matter. I usually like to pick something in the middle, which is -4, and put that into my equation, into my calculator, and for all of my x's, and check if that is greater than 0. So -4 squared plus that gives me -1. Is -1 greater than 0? No. So it can't point this way. Also, I forgot to do my circles, but it's just a greater than, so these get open circles, and they cannot point at the -4, so they must point to either side. This last one, I have 3 numbers, so I have x equals 0, x equals 6, or x equals -2. Putting those on the chart would be in this order. So now I have a bunch of different regions to check. I'm going to start by checking something in between the 0 and the 6. So I'm going to pick 1. So I have 1 parenthesis, 1 minus 6 parenthesis, 1 plus 2, and see if that's greater than 0, which is -15, which is not greater than 0, so that one cannot be pointed at. Also, these are all open. So since I can't point at that one, I have to point these this way. And then I'll also check a number in between here, which is -1. So I'm going to do the same process, but put -1, which is 7. Is 7 greater than 0? Yes. So this one has to point there. Now we're going to go back to chapter 2 where we talked about interval notation, and we are going to write each of these answers using interval notation. So on this one, I see that the solution set is in between my 2 numbers, and they're closed circles. So I'm going to use brackets for both because they're closed, and write down my 2 solutions with a comma. So this means that all of the x's are in between -5 and -1. On this one, they're pointed to -infinity and to positive infinity, and infinities always get a parenthesis. So the first one goes from -infinity up to -5, and -5 isn't open, so it gets a parenthesis also. And the second one starts at 3 and goes to positive infinity, so they both get open parentheses. Number 3, I have 2 things going on again. The first one is anything in between -2 to 0, but open circles, so open parentheses. And the next one is from 6 to positive infinity.